Oh, hello. My name's Haiyan. I'm Innovation Director at Microsoft Research, Cambridge, just down the road by the station. And today I'm here to talk about empathy and insight in new technology development. So I call myself an engineer, a designer, and a maker of things. So I started out in computer science, doing software engineering. I then transitioned into innovation and design, and I worked at an innovation consultancy called IDEO for about 7 years. And then I joined Microsoft about 5 years ago, initially in Xbox, running an incubation team around new gaming and play experiences. And then 3 years ago, I joined Microsoft Research. And so Microsoft Research was founded about 27 years ago by Bill Gates as a computer science research organization. And the company looks to us to influence new technology thinking and to invent new software and gadgets for the upcoming sort of new technology age. And we've expanded into about 8 different labs around the world. Cambridge was actually the first lab outside of Microsoft headquarters. And we have about 150 people in the building, so please come visit us if you're sort of staying in town as well. And at the lab, we say that our mission is about transforming the world through deep collaborative research. And we fundamentally believe in this cross-disciplinary approach to doing computer science research. So we have researchers from machine learning to computational biology to human-computer interaction to design to confidential AI and security. And so what I wanted to talk to you about today was some of the work that I do with my amazing colleagues, and something that I think underpins how we should be thinking about developing new technologies and research, which is I'm sort of starting to formulate this idea around insight-driven research and technology development. So what do we mean by insight? Well, according to the dictionary, it's this capacity to gain an accurate and deep understanding of someone or something. And I'd like to think of it as an elusive, encapsulated wisdom, so that when we're thinking about our research or our engineering projects, we need to be able to articulate what are the insights we've gotten, whether they're about users, whether they're about people, or whether they're technical insights. And these insights give us the advantage over our competitors in developing new products. So as an example, Thomas Edison, one of the first patents that he filed was an automatic vote collector for the American Congress. So he came up with this brilliant idea. Well, when the Congress is sitting, when the politicians are voting on a particular bill, it's hugely inefficient because it takes ages. They have to stand up, they have to say what their vote is. What if we had a button at every seat? And when it came time to vote, they just pressed the button. So he actually invented this device, and he took it to Washington, he took it to Congress, and it was a huge failure. And actually, one of the congressmen said, it was a famous quote, he said, "If there is one invention we do not want here in Congress, it's this thing." Now, why did it not succeed? Well, at the time, what Edison, he didn't have insight into, what he didn't realize was that in Congress, the politicians, they love to stand up and have their 5 minutes. When it comes time for voting, the vote is not just about lodging your yes, your yay or your nay. It's about standing up and making a comment, or sometimes they like to stand up and do this filibuster thing in the US where they just talk for hours and hours until the voting time elapses. So because Edison didn't have this insight, his first invention was a failure. And it taught him a lesson in that subsequently he really looked to establish, if there was that human need for what he was inventing. As another example, a gentleman by the name of Gilbreth in the 1920s decided that he wanted to look at the process of bricklaying. Now, humans have been laying bricks for 6,000 years, and it really hasn't changed that much. And what Gilbreth did was he used a movie camera to capture people laying bricks, because he was really interested in process and gaining insight into a process that people really hadn't looked at for 6,000 years. So he just filmed bricklayers, and he discovered that within 1 hour, a bricklayer stoops down and picks up a brick 125 times. And then he stoops down and gets mortar 125 times. So every hour, this bricklayer is stooping 300 times. And he realized that that caused huge inefficiencies in the entire system of bricklaying. And he, based on this insight, he developed a scaffolding, a brick, which is basically raise where the bricks and the mortar sit up to your waist level, so you don't have to scoop down. And this increased the efficiency of the bricklayers by 100%. So I think this is one of the earliest examples of using observation and using new technology tools to really understand how people perform activities, perform their jobs, and to gain new insight to develop technology to support them. And so for me, in the work that I do, I believe that insight is key in creating novel, impactful technologies. And that might be insight at a higher level in terms of establishing your project, but it might be a granular insights at every stage of the way to understand how you should direct your feature set, how you should direct the design of your user interfaces. And what I've found through computer science and through design is that this cross-disciplinary nature of working and leveraging processes and methods from design is a great way of repeatedly gaining insight into a problem. Those might be human insights, and they might also be technical insights. So I'm going to walk you through some of the projects that I've undertaken in the past few years, mostly with the BBC in collaboration on a documentary series called The Big Life Fix. So this is a documentary series that really sought to highlight challenges that people are facing in the UK, and to bring together engineers, technologists, designers in order to solve those big challenges and to document that process. And I think in a way to push forward STEM education and the understanding of the engineering process in the UK as well. So I'm going to start with a young girl, Aman. And Aman, when she was about 8 years old, she was in a terrible car accident with her family, and she sustained really dramatic brain injuries. Now, this is, of course, in her initial phases of her injury. She was in hospital. And when she first woke up, you know, she couldn't talk, she couldn't walk, and since then she's really regained a lot of that ability. But the one sustaining injury has been her short-term memory loss. So she has trouble remembering things that occurred about 30 minutes ago or occurred a day ago. So she's highly functioning, she's in the moment, she can do her tasks, but over the long term, she has trouble remembering what she's experienced. Sound and...
I don't remember.
I don't remember.
Do you remember where we went to eat?
No.
So I started tackling this challenge. You know, when you're presented with a problem like this, how do you even go about mapping out what the problem is, and is it even possible for there to be a technology solution? So I connected with researchers at Cambridge University that are looking at memory deficits, and we mapped out her short-term memory loss, which we discovered was not really short-term memory loss. It was a type of episodic memory loss, which means that she has trouble remembering events. And and to some extent, the researchers said people with this kind of episodic memory loss, they may never experience the emotional highs and lows that we would experience about our past memories. And from there, we mapped out where in Aman's life might she benefit from a technology solution that would just get her through her teenage years, get her into high school. So we sort of identified that in school she has trouble remembering her classes. So she actually sits in a regular school. She has a adult helper sitting with her at all times, but she has trouble remembering the classes, remembering the activities the teacher has set. And for her family memories, she has trouble remembering spending time with her family. So she, on weekends where her family will go on a picnic, and she will not remember that picnic the week after. And this causes intense frustration, is actually influencing her personality because she gets really frustrated. She goes upstairs and slams the door. So we're really trying to figure out, well, how can we gain an insight? Can technology even help in this case? And one of the activities that I did with her was I took her punting in Cambridge. So we went on a punt, and just to see how she does in this kind of family memory and a kind of a lovely setting. And then I didn't give her any technology tools. I gave her a Polaroid camera, and I said, well, why don't you just take Polaroids of interesting things that you see during the trip, and we'll look at them later. Because there has been research, at Microsoft Research as well, from some of my colleagues about using photos in order to jog people's memories, which actually started the life cam, life logging industry. And so we did this, and what was really interesting was that Aman was taking photos of throughout the trip of things that she was seeing, but what she was particularly taken by was our punter. Now, I don't know if you've taken a punt in Cambridge, but I do note that the people doing the punting are, I think, recruited, but to be particularly perhaps on the more attractive scale of Cambridge students. And so Aman was really taken by her punter, and she started saying, oh, he looks like Niall from One Direction. And she was sort of taking photos of him and giggling, and I thought, oh, this is really interesting. And then afterwards, we sat down in a cafe. So 40 minutes later, we sat down in a cafe. We had all the Polaroids in front of her. She's looking through the Polaroids, and she didn't remember this guy, even though just less than an hour earlier she'd been so intensely excited. She didn't remember this guy, and at that point, her mum, who was sitting with her, started reminding her, started telling her the story. And she said, "Aman, do you remember this guy? You thought he looked like Niall from One Direction." And when her mum was telling her that story, Aman's face lit up, and she started remembering this guy. And for me, this is an insight into, Aman is sort of like a black box, and we're trying to just interrogate this. We're trying to put her into different situations to understand what are the moments where she might be able to recall something. So just based on this insight that her memories might be jogged by stories or familiar voices of her family, we created a simple little technology tool, which is a website, but also a mobile app where her family could, from all over the world, could upload photos and then record audio stories associated with the photos. I mean, it's very simple, but there wasn't any tool around that would do that. We see all these social media sites, Facebook and Instagram, but there wasn't a single tool that would allow us to derive this kind of feature set. So we just built it from scratch. And then there was a feature to also export it as a little home movie. And so then we did this, and we exported this movie, and then this is the result of Aman seeing her family memories and hearing those stories for the first time.
Memory
my brain.
sparks.
My
Yay! probably one of your first times that you joined in Monopoly.
I don't remember
It
that.
must have been about. But you still had that smile on your face, Summers.
I remember that. I remember that.
So you can see that, you know, just through this very simple understanding of how Aman's brain works, we can create technology tools to support her. So that's one of the sort of earlier stories, projects that we worked on, and we're trying to develop out this platform, this little tool, because I've been contacted by various care centers about perhaps scaling this up for other kinds of patients. So next I want to talk to you about another project we did, which was very much driven by this insight process, which was around Emma. So Emma, when she was 29 years old, she was diagnosed with Parkinson's disease, which is very rare. It's early onset Parkinson's. And she's now about 36 years old, and her symptoms have progressed quite quickly, particularly around tremors and her ability to write and draw. And this was very important in her life because she's a designer, she's a creative, she's an art director. When I met with her, she was really challenged in doing her job. She had to sit with a colleague in meetings where the colleague would write for her and draw sketches for her. So it was a debilitating illness for her, and you can see a writing sample. And so this is, I mean, to me, I didn't really know anything about Parkinson's disease, and it was really inspirational meeting Emma. But sometimes you go into these challenges and you just don't even have a hunch that technology could help in any way. So I'm going to show you a clip of the process that we went through in order to develop a solution.
Right, I'm going to try and replicate this here. We're off to a great start. I tend to kind of just avoid doing sketching and writing now because it's not really worth it if you get something like that. Anything you could do that would just make my hand do what I want it to do and to be able to sign my name would be an incredible thing.
How do we even just begin to help her overcome this particular symptom of her tremors and helping her be able to regain her writing ability, her drawing ability? You know, I don't think we're ever going to get that back 100%. You know, my challenge is I mean, it's immense.
Someone's made a spoon. It actually counteracts the tremors you get from Parkinson's. So the spoon actually vibrates in opposition to how your hand might be shaking, and therefore it is steady. I'm making a very rough prototype. And what this board does is I can connect into it through these wires, these tiny coin cell motors. So these motors will vibrate. Hello.
Hi, I'm Alison.
It's affecting something. I don't quite know what's happening. Something is going on with it.
What this is doing is it's short-circuiting whatever feedback loop there is between the brain and the hand that's causing the tremors. I'm on to something, right? I'm on to something.
Woo! Woo! Jesus Christ.
Oh my God.
it makes me forget that I have a tremor. I haven't drawn one of them for a long time. I'm so casual about it. Yeah, I'm just going to draw a straight line. I've actually just written my name for like the first time in ages.
I can't believe it.
Mum, it's called the Emma.
Oh, brilliant.
It's got my name on it.
So you can see that that video really captures the process that we went through, and this is some of the contrast in the effect of the watch. And I just wanted to talk about sort of the actual research process we went through. You know, I think what's really interesting is that for me, I think this highlights that one is, I notice how I talk about these stories is that they're intensely human stories, but they're also technology stories. And I think there is huge value in thinking about technology in terms of these human stories, in order to also just make them more accessible to the world about what we do. Secondly is that this cross-disciplinary way of working and always striving for insights, I think is encapsulated in this project, where when I started this, I didn't think that we would be able to come up with anything. And I started to look at ways to really control her hand. So we're looking at pens stuck to magnets that would sort of magnetize to the desk so that she wouldn't be able to move freely. And Emma and I went to visit Parkinson's UK, and they just had a table full of gadgets that people with Parkinson's use to try to help in various aspects of their symptoms. And some of these have come from medical research, but some of these have just been anecdotal things that people have discovered that works. And one of the things that was on the desk was this sort of digital metronome. So this is a device that musicians use when they're playing the piano, when they're playing kind of music, and it just makes a regular ticking noise. And then you can set the beat, but it just makes this regular ticking. And I asked, well, what does this device for? Why would people with Parkinson's want to use this device? And someone told me that there's another symptom in Parkinson's called freezing gait, where when you're walking, you suddenly lose control of your legs and you can't move your legs. And sometimes people have found that when they take out a metronome, when they have a ticking sound, and they listen to the ticking sound, it distracts their brain into somehow regaining the ability to walk again. There's been a little bit of lab research around this as well. And so I found this really interesting because it gave an insight into what might be happening in the brain with Parkinson's disease, that instead of thinking about mechanical fixes, we could think about ways to hack the brain. And so I had a hunch that perhaps we should think about a rhythmic, regular ticking or an injection of sensory input, and then using vibration rather than sound on the wrist, because the sound was working in this freezing gait scenario, but not in the riding scenario. So this is one of the later prototypes. So we created this watch with motors along the band that would vibrate at a regular pace. And we are actually arm powered. We're using the latest model uses the Cortex M0, and we just tried it out along with a number of other prototypes, and it really worked well in Emma's case. And so I think her quote is really poignant here in that we're creating this kind of technology. It's not to solve the problem, but it's somehow making her life and making her outlook slightly more improved, and therefore can have that dramatic dramatic effect on her. And since then, we've been partnering with the neuroscience department at UCL in order to further the research into the watch. So we've been developing software to do lab testing, to do clinical testing with patients using the watch. So it's been an interesting process. It's also been interesting working with neuroscientists who are using accelerometers from the 1980s, which hooks up to a giant machine in their lab. So I think it kind of going across disciplines and seeing the technology being used in other fields of research and try to improve those tools as well has been, I think, really valuable. And so I wanted to also talk about another story with a young boy named William. And William and his parents, they live near Southampton, and recently I sort of met him. He's about 4. When he was born, he was born with a heart condition, and he had to undergo surgery. And something went wrong in the surgery, where he had a blood clot that went to his brain, and his parents didn't realize this. No one realized this until it was he was a bit older, and he started having really terrible epileptic seizures. So terrible that he's categorized as being at risk of sudden death from epilepsy, which means that his parents have to monitor his seizures. And if he has a seizure that lasts longer than 10 minutes, they must administer medication, or he's at risk of not waking up from a seizure. The other challenge is that his seizures are mostly occurring at night time. So his parents have been taking turns staying up at night, watching him, fearful that he might have sort of the next big seizure. And then so I think they haven't slept for years. And so I went and visited them to try to understand their challenges and to see the sort of ecosystem of tools they're using and how that's not working for them, and to think about, well, how can we create something that would help his parents? And I think initially they wanted an epilepsy detector. And I think that is a challenge for us, that can we create technology that is foolproof and detects seizures 100% of the time? And I think that is ongoing research. But through this process, I discovered that in creating a prototype, it would be very challenging and almost impossible to create a 100% epilepsy detector. So how can we use technology in other ways to reframe the problem?
Oh, he's easy.
Okay? Just lay him down.
5-year-old William has epilepsy.
Oh, it doesn't matter how many times he does it, it still kills me every time.
His parents, Pete and Tanya, have to watch him day and night. If he doesn't recover within 15 minutes, he has to go to hospital. Computer scientist Haiyan has come to help. Standard nighttime epilepsy monitors don't work for William.
Unfortunately, it's never picked up one of William's. 1, he's too light. 2, the sensors are very specifically placed, and he's never really sleeping centre.
His parents take it in turns to stay up at night to watch him on a screen. They use phones to time his seizures and keep track of when they give him medicine.
You know, it's that constant anxiety, that constant worry.
What we have is odds and ends cobbled together in a kind of piecemeal solution. I don't know how much longer we can do it for. I'm seriously just too tired.
It's one of the hardest challenges ever faced by Haiyan and her fellow inventors.
How can we ever be assured that we could build something that could detect his seizures 100% of the time, so that his parents will feel will feel safe to go to bed? Because if there was one time out of 1,000 that it didn't detect it and something went wrong, I don't think we could guarantee that we could build anything like that. What we want to do is make a monitoring system, not an alarm system. I think the best people to detect when William's having a seizure is his parents. And we can just make their lives so much easier through technology.
Will Haiyan's invention change their lives?
Haiyan, Haiyan's here.
Here we go.
Look. Wow, look at that, William. William, look.
It's called the Aura, and it's an integrated monitoring system for William. So the Aura Hub is streaming the video and also sound, but the other thing that you can do, which is what's special about it, is that if you didn't want to watch the video, you can...
This is heartbeat.
This is heart rate,
It's
wow.
William's heartbeat.
That's amazing.
And if it goes above the danger level for the heart rate, it'll sound an alarm. But you can also have...
Oh, wow.
It's just so much calmer than just staring at that screen, almost waiting for something to happen.
When he does have a seizure, you can start the timer.
Oh my God!
Oh, man. It's a fantastic idea. We're there struggling with our phones, trying to turn the torch on and try and look at the time.
It's become so normal for us, hasn't it? For one of us to sit and just watch that monitor. It's just kind of suddenly dawned on me that, you know, we don't have to. Oh. It's going to massively help.
Again, another really challenging project and really sort of emotionally charged as well. But I think underlying it, even though we couldn't create an epilepsy detector, and I think we did try to use some machine learning methods to classify seizures. I think the challenge was being able to capture the data, having enough data to train with, and we definitely weren't in the position to do that. So I think that's sort of, ongoing challenge to you guys, the research community, to look at some of these problems as well. But ultimately, I think the insight that we were driven by was this idea that, there are monitoring tools out there and there are technologies out there, but there's some of them lacking this fundamental insight that what the parents need is they need the reassurance that part of what's making their lives so difficult is the stress that they're constantly experiencing. And they need that constant reassurance that their boy is okay, not just the alarm event of of sirens or alarms, sounds going off to tell them that something's gone wrong. So we tried to create a reassuring monitor where if they weren't staring constantly at a black and white video stream, they could at least have some understanding that the system was working and they could understand sort of the state that their boy was in a process that didn't overload them cognitively. So you can see that this project is really kind of reconfiguring these systems and bringing them into one place, but hopefully being more effective in gaining that insight, gaining that understanding of how the parents are living. And so finally, I want to just talk to you about another project, and recently we've actually launched this with Great Ormond Street Hospital and with UCL to do a longer-term research study. And this is tackling a challenge of cystic fibrosis. So cystic fibrosis is a life-limiting illness. It's a rare illness. It's a genetic condition. It only affects 1 in 2,500 babies. There's about 100,000 people globally living with CF. So from a scaling and from a business point of view, I think this community's really struggled to get products created specifically for them because it's such a small population. But we have to understand that the reason the population is small is because it's life-limiting, and the average life expectancy is currently at about 41 years of age, and that's improving over time with new antibiotic research, new medical research. And the specific challenge we were facing was that this is Vicky. Vicky is a mum of 4 kids, and 2 of her boys have cystic fibrosis. And the boys are now teenagers, and when you have cystic fibrosis, you have to do medical exercises twice a day, every day of your life. You have to do this kind of breathing exercise where you take these plastic breathing apparatuses that were designed in the 1950s, and you have to breathe into them, and they limit your breath, and they sort of create a sort of vibration in the lungs that escalates the mucus out of the lungs. And if you're doing this twice a day, and it's incredibly laborious, when you're a teenager, you don't want to do it anymore. And Vicky found that every single day she was arguing with her kids. She was becoming a nagging mum. Her boys were acting out, and she couldn't get them to do their exercises. And one of the problems is that you don't see the immediate effects of the exercise. In that you don't immediately feel better. You don't immediately get worse if you don't do the exercises. But over the long term, it prevents the boys from getting infections, from having to go to hospital. So she was really struggling with figuring out what to do in this case. And so I went and I met with the family, I met with her, and for her, she actually had this insight herself in that her boys and all her kids really enjoyed playing video games. And she said, well, what if we could turn the cystic fibrosis treatment into a fun session? Like, what if they could play video games as they were doing the medical treatment? And so we started out trying to create prototypes where we could turn the breath going into these breathing apparatuses into some kind of digital signal that would allow us to control video game. So this is a really early prototype. And one thing that we uncovered was that once you start capturing this breath as digital data, you could start mapping it, and you could start analyzing it, and you could capture over the long term, which was incredibly useful to physiotherapy researchers at UCL as well. So we created a device which eventually became more streamlined, and so here's our team member Greg testing it out. And so the breathing controls different kinds of video games. In this case, there's one button on it. So we added one button because we found that just using your breath to do a video game was really difficult. So you breathe to do one action like running, and then you press the button to jump. And we found that, especially for these teenage kids, we wanted to actually create custom.
There it goes.
Sorry, we wanted to create more custom games. So we actually created the technology platform, and we ran hackathons to hack these games. So volunteers from a sort of computer science and video game degrees across the UK come together, and we've run several of these, also in conjunction with Microsoft UK, to create new kinds of games that then can be sort of uploaded to a app store that the kids can then download. And so I just want to go back and show you guys okay, so then here's the boys trying out some of the games for the first time.
There it goes. He's taking off. Aiden's
Come on, Red.
Look at the concentration on his face. We don't ever get that with this, and it's working.
And that coughing is what's needed for cystic fibrosis, isn't it? That's loosening mucus.
Blowing into tubes makes cars race.
Come on, Red.
Come on, bro. Come on, Margaret. Come on.
This is the best thing that could ever happen for us, because I just know that the hardest thing for him to do is physio, and that is the only thing he needs to do to get better.
That I'm going to be doing it probably every day now. Like,
I think
without mum asking me.
So we started out working with one family, but the problems this one family faces scales across the entire community of families that are living with this disease. And so we were approached by Great Ormond Street Hospital and UCL to say, well, what if we could take this platform that we're building, which comprises of a device that connects, that has a universal adapter that connects to various different breathing apparatuses, but also uploads the data to the cloud for further analysis. And there's also a game download portion where you can access different kinds of games. So what if we could take this entire platform, this end-to-end platform, and scale it up for lots of kids across the UK? So we've been working with the hospital and UCL, doing hackathons to generate more games. And just last week, Great Ormond Street's launched this as a clinical trial with about 150 kids across the UK. They're going to be running this for about 2 years. And for the researchers at UCL, you know, to them, they, when I first met Professor Eleanor Main, she was running this department, working with kids with CF, and did not have any contact with the computer science department. They basically had been working with kids in terms of physical exercise, in terms of getting them to do the physiotherapy. And we started partnering on this about 2 years ago. Since then, she's developed this as a program within her department. She's hired a data scientist to do the analysis. Great Ormond Street have this great platform for pulling in the kids' patient data and correlating that with the data that is being uploaded from our device. So her team is able to then track the long-term progress of these kids and to understand whether this kind of physiotherapy, what real impact it has on the kids' long-term health, because nobody's actually been able to accurately track this kind of treatment before. Past research has always centered around diaries that you fill in, which, you know, can be, the kids might be fibbing on the diary. So we're able to accurately capture that data and to accelerate the research in this area as well. Great. So I hope that you've enjoyed and been inspired by some of these challenges and some of these projects. And I hope in the work that you do and you move forward with, that you'll think about how to gain deeper insight into people or into some of these technical issues using perhaps lateral thinking or observation techniques. I'm really happy to answer questions after the session. We've got 10 minutes spare before the fire alarm. So thanks very much, guys. Thank you. Do you want to, should we do questions or should we? No? Yeah. Does anybody have any?
One of the aspects of those very inspiring stories which you told are that you are in the position to apply. You are in the position to apply quite expensive technology to specific solutions, which the
market. Was it expensive? No, I don't think so.
Okay.
Really?
Expensive in terms of researchers' time, if not in terms of LEDs and circuit boards. What I'm really coming to is, do you think that some of these solutions will now go mainstream and that it really just took your initial sort of seed crystal to show that this was possible? Or is there a real problem with the market delivering these solutions?
Oh, well, I think it's all those things, right? Most of these projects were done on our spare time, really. I wouldn't say that they were expensive projects to do, but they were quite expensive in terms of kind of, I think, emotional investment and obviously time investment beyond office hours as well. I think there was an interesting article in The Guardian this weekend about new businesses and solutions for disability and for people with disability. I think there was an example of someone who was creating custom wheelchairs for different kinds of environments, for different activities. And the challenge is always, how are we going to deliver this? How are we going to scale this up and actually deliver it to the community? And that is still something that I'm working through, but hopefully others in the tech and entrepreneurial communities are working through. I wouldn't say that there's a standard business model. You know, there are social enterprises, there are charities. We have another project that I didn't show today where we developed a toolkit to support sight-impaired kids to learn programming. So we developed a physical toolkit, and that's being taken forward by a charity that is in the business of selling products in this market. And so we've created the entire pipeline in terms of the manufacturing and the software, and then they're going to take that forward. So for each of these cases, we are looking for, I think, bespoke ways to move these forward, because each of these industries is very different. The CF industry is very different from a Parkinson's device industry. Some of these, I think, will succeed in that scaling up, and some of them may not succeed, but hopefully by being able to show that we can leverage technology in new ways to support people, especially I think in the Parkinson's case, where I think we can show that there is still new thinking, there's still new ground to be broken through combining technology research with neuroscience research. I think that's the key here, is that when I met the neuroscience researchers at UCL, you know, they hadn't really gotten that connection with the computer science department. To kind of bring those two forces together will generate groundbreaking solutions. I think that's key as well. Thanks.
Hey, so thanks for the talk. It was great. I'm interested in your process. What does the team look like that you have to go and get the insights from your end users or patients?
Well, very small team. A lot of these, I did the user research myself, and then I work with my colleagues back at Microsoft Research to do some of the prototyping, and to kind of, I made this prototype, and then we sort of worked together to design the custom PCBs and create the 3D.
Could you say a little more about how you go about interviewing an end user, or the process used to gain those insights?
Oh, I see. Well, I would suggest really then looking into kind of design methodologies, and there are toolkits out there where you can have a selection of different methods, and you can pick the methods that work for you. So things like, creating an activity and taking your users on an activity and then observing them through that activity. But I think ultimately it is it's really interesting, because we all have the ability to talk to people and to understand their situation, but to really, I think, draw out insights is a skill that you can hone. And I think it's part of how you ask questions and how you're observing and listening and watching them as they go about these activities. So I would suggest looking into kind of design methodologies for doing user-centered research.
Has anyone adopted Emma commercially?
So we're just working, actually I had a really good meeting last week. I'm just working through that at the moment. It's been kind of a slow process. So one of the things I want to do is I want to collect enough evidence to then have a sort of, to say, well, it helps Emma, but it also helps this percentage of people with Parkinson's. And then to take that to a business, whether that be probably a manufacturer, but also some sort of a business that already sits in this market, to try to develop it as a product, because I want to make sure that we're quite responsible in the way that we move forward with it. So it's slow, it's in the works. I've never done sort of clinical testing before, but it's a very slow process. It's easier to work with one person.
So I was really excited about your prototyping experience. When you look at the mobile systems research community, I get the sense that there's a lot of work on going to the mobile phone first and repurposing existing sensors and computational platforms for it. So from a design perspective, how do you decide I'm going to build my own sensors and actuators and computing platforms, customized versus go and take a mobile phone and figure out how to use sensors, get it hooked up to the phone and get something interesting there.
I think that's a whole other talk to talk about prototyping methodologies. I'd say that today I find it much easier to take an off-the-shelf platform like Arduino and just make a quick and dirty prototype to test things out. I think ultimately you got to think about, if you're deploying this with people, there is a gap within their lives where they could fit this technology in. Now, is that a mobile phone or is that a custom device? Because there are, I think when we deploy our devices, there's always the challenge of, well, is this going to Bluetooth? Is this going to connect via Bluetooth to a device? And then we've had trouble where, someone might have 3 different Bluetooth devices and they just have problems with connecting the Bluetooth device to the tablet or the mobile phone. So I think I always prefer a custom device, unless a mobile phone is just going to make things much easier for them. So, yeah.
Quick question. I didn't quite understand in the Emma, is it creating a fixed vibration, or is it a feedback sort of based vibration, or something like that? So
in the Emma case, she manually tunes, so she manually adjusts the vibration based on how she's feeling. We could potentially look at feedback loops, but at the moment, because if she just picks a setting and it works well, I think it works, it's covering like 80 to 90% of the success, so.
You couldn't use something like noise cancellation uses?
Noise cancellation is a slightly different effect. So what we're doing is how the brain is working is the brain creates a model of how your arm is going to move when you are instantiating the movement. So it models how much force you should apply, what's the angle of movement. And we think with Parkinson's what's happening is that the brain takes sensory input from the limb and then adjusts the model as you're moving. So for example, if you're holding a tray with some glasses on it and you're walking, you're balancing it all the time. So you're adjusting, how your brain is adjusting the model based on the sensory input. When you have Parkinson's, we think that there's something wrong with the sensory input. So the brain is receiving erroneous sensory input and it's constantly making the adjustment, which is causing the tremor. So if you're receiving the incorrect signal, your brain's incorrectly adjusting the model and you're tremoring. And we think that the vibration is actually just telling your brain to ignore or downgrade the sensory input from your hand. So the brain is just going on its own internal model because your brain has an internal model of how you should be moving and it's just not taking the sensory input into account. So it doesn't quite work as noise cancellation works. Oh. So at the moment, we've only tackled the drawing and the writing. So it's a very limited window within which we're testing. And it's taken us a year to just run our first set of studies with this very narrow protocol of testing different writing activities on various patients. It would be great to expand it out, but this is the challenge where I think we accelerated very quickly and we bootstrapped this project, and now we're hitting kind of the sort of challenges with medical research and being able to work with patients, especially with GDPR coming into play. So I think that's some of the ongoing challenges. Yeah, but that would be great to kind of move that forward. Yeah.
Okay. I was going to say, well, thank you. Let's thank our speaker again. Thank you. Thank you very
Thanks,
much.
guys. Cheers. Thanks.